Hi grade 12 and welcome. In this video we will be studying trigonometric ratios and trigonometric identities. So let's have a look at, when we study trigonometry, obviously we are dealing with sides and angles. So let's look at this triangle here, and I'm going to put some values so we can basically prove them. But in general, if we have x, y and r, so we know x squared plus y squared is equal to r squared from Pythagoras. Now when we say sine theta, the theta angle is here, right? So we can clearly see that this is the opposite, this is the adjacent, opposite angle theta, adjacent, and the hypotenuse can never ever change. So that's the hypotenuse, that's the opposite, and this is the adjacent. Now when we say sine theta, that's opposite over hypotenuse, so this is y over r. Cos theta is here. Cosine theta is basically x over r, adjacent over hypotenuse. There's it here. Cos represents adjacent hypotenuse, and tan ratio is opposite adjacent. That's the reason why we use SOHCAHTOA. Tan is y over r. Next, cosec is basically the is r over y, is the reciprocal of sine. Sec is a reciprocal of cos, so it will be r over x, and cot is a reciprocal of tan, so that's that should be y over x, opposite over adjacent, so that should be y over x. So this is y over x, so cot is a reciprocal of tan, it should be x over y. Okay, now since we did reciprocal ratios, what we can say here is that cosec is 1 over sine theta, sec is 1 over cos theta, and cot is 1 over tan theta. So I hope you guys are understanding. Next, we want to check what's the expansion for tan and cot. So if I try to find what is sine theta over cos theta, then we have an angle here. Let's put some values. If I put 3, 4, 5, if I use that triangle there, we know sine is opposite over hypotenuse, so that's 4 over 5. And if we divide it by cos theta, which is 3 over 5, right, then what do we get? We get 4 over 5 divided by 3 over 5. 4 over 5 divided by 3 over 5, we keep change flip, 4 over 5 times 5 over 3. The 5's cancel out, we get 4 over 3. And clearly 4 over 3 is a tan ratio, so what we can say is that this is tan theta. So what we know is that sine theta over cos theta is equal to tan theta, because we can clearly see this is 4 over 3 is tan theta. If you can just write down the what is sine cos tan in the sides, so we know sine theta is 4 over 5, we know cos theta is 3 over 5, we know tan theta is 4 over 3, and then cosec theta is basically 5 over 4, sec theta is 5 over 3, and cot theta is 3 over 4, the reciprocal of this, so 3 over 4. Now let's look at what is cosine over sine theta. Cosine is 3 over 5, and we're going to divide it by 4 over 5 sine theta. You can look at it from here. So we have 3 over 5 times 5 over 4. So we get 3/4, and we can clearly see 3/4 is adjacent over opposite, and adjacent over opposite is, remember this is adjacent, that's opposite. Adjacent over opposite is cot. So this is cot theta. Okay, so what we have learned is that cos over sine is cot theta. Now if you go back up, remember if you're going backwards, hypotenuse over opposite is cosec theta, hypotenuse over adjacent is sec theta, and adjacent over opposite is cot theta. So SOHCAHTOA gives us 6 trigonometric ratio, which is sine and cosec, cos and sec, tan and cot. Now we want to prove square identities. What are square identities? We will look at the same triangle 3 4 5, and we have theta here. So first we want to prove what is sine squared theta plus cos squared theta. Now this works for every single triangle, whether you have x y r, whether you have this Pythagorean triple or any other Pythagorean triple, right? So let's go and see what's the value. What is sine squared? Sine squared is 16 over 25. Cos squared, cos is 3 over 5, so if I square this I will get 9 over 25. 16 plus 9 is 25 over 25, and that value is equal to 1. So we know sine squared plus cos squared is 1, and that gives us an identity. Next one we want to prove is cosec squared theta minus cot squared theta. Cosec squared is 25 over 16 minus cot is 9 over 16. So what we get is 25 minus 9 is 16 over 16, and that's also equal to 1. So that's the second square identity that we know. Next one, we want to prove that sec squared theta minus tan squared theta. What is sec squared? 25 over 9 minus tan squared is 16 over 9, and we get 9 over 9, which is also equal to 1. So what we know is that sec squared minus tan squared is also equal to 1. Right, so I hope you guys understood this. So what have we learned? We learned SOHCAHTOA, we learned the reciprocal ratios. We know cosec is 1 over sine, sec is 1 over cos, cot. We learned sine, tan and cot identities, and we learned square identities. Now let's do some practice questions. So in triangle ABC, AB is equal to 5. So here's a triangle, right? We know AB is equal to 5. Now how do we fill in this triangle? Start with theta. So fill in angle C as theta here. And we know that AB is 5. So this will be BC is 12. So put B here. BC is 12. And AB is 5. Make sure your triangle is in order. So we have 5, 12, 13 triangle. You can solve for the hypotenuse by using Pythagoras. Square root of 12 squared plus 5 squared, which is 13, and we have learned this in Pythagorean triples. So calculate the values of the 6 trigonometric ratios. So basically we want sine theta, and we want cosec theta, we want cos theta, and we want sec theta, we want tan theta, and we want cot theta. So we have SOHCAHTOA, right? In SOHCAHTOA, that's the opposite. 5 is the opposite, right? And 12 is the adjacent, because adjacent means next to theta is 12, and the longest side is always the hypotenuse. That cannot change. Now what is sine theta? Opposite of a hypotenuse. There's it here. Opposite hypotenuse, 5 over 13. What is cosec theta? 13 over 5, the reciprocal. What is cos? 12 over 13. And what is this? 13 over 12. What is tan theta? 5 over 12. And what is cot theta? 12 over 5. Adjacent over opposite. Remember this SOHCAHTOA. That will give us all our 6 trigonometric ratios. Now moving on from the diagram in question 1. So that's the first question that we have done. Find the values of the following, right? So same diagram, we got 12, 5 and 13, and we got theta here. What is sine squared plus cos squared? We've proved it before, sine squared plus cos squared, but using the diagram, sine squared is 25 over 169 plus cos squared is 144 over 169, and we're getting 25 plus 144, 169 over 169, and that's equals to 1. Cosec squared minus cot squared. Cosec squared is 169 over 25. 13 squared is 169, by the way. And remember that's a minus here. So minus, what is cot? 144 over 25. Okay, 144 over 25. If you take 169 minus 144, you get 25. So you're getting 25 over 25, and that's also equals to 1. Next one is sec squared minus tan squared. Sec is 169 over 144. minus, what is tan? 144, tan is 25 over 144, tan squared, and 169 minus 25 is 144 over 144, and that's also equals to 1. And we can clearly see that we did it for a different triangle and the answers are all 1. So these are your 3 square identities. You can't forget them because we need it for simplification of trig equations, trigonometric proving trigonometric identities and stuff. Now what is sine theta here? Sine theta here is 5 over 13, and we're dividing it by cos theta, which is 12 over 13. Now you keep this, you flip this, and you change this. Keep, change, flip. So this is 5 over 13 times 13 over 12. Now 13 and 13 cancels out, you're getting 5 over 12, and you can clearly see we just wanted a value. Alright, we want values, so 5 over 12 is kind of like tan theta. So instead of doing sine over cos, you already know that's tan. Tan is basically 5 over 12, and we got that answer. What is cos over sine? That is cot, but let's just do cos over sine, which is 12 over 13, right, divided by 5 over 13. Where we got 12 over 13 and 5 over 13, cos theta is 12 over 13, there's it here, and sine theta is 5 over 13. So we got 12 over 13 times 13 over 5. So what we get, 13 and 13 cancels out. Remember, why does it cancel out? Because you can cancel one from the top, one from the bottom when it's multiplied by each other. So we're getting 12 over 5. 12 over 5 is clearly cot theta. So there's all your tan and cot identities. Right, so it's very important to learn these. Now moving on to the next question, what we have here is, okay, so we got 3, 5, so obviously the opposite is 4. It's a 3, 4, 5 triangle because of Pythagorean triple. So what is sec theta? So if I write down soca toa, remember that is cosec, CSC. This is sec, hypotenuse over adjacent, and adjacent over opposite is cot. So sec is, so look at it, look at this, that's the opposite, that's the adjacent, and that's the hypotenuse. So opposite, adjacent, hypotenuse. What is cosec theta? Cosec is hypotenuse over opposite, cosec, but we wanted sec. Sec is hypotenuse over adjacent, 5 over 3. So that's 5 over 3. And what is tan? 4 over 3. Opposite over adjacent. 5 minus 4 is 1/3. So my answer is 1/3. The answer for this problem here. If sec theta equals 13 over 5, then find tan theta. Now you have to draw your own triangle here and solve this problem. Right? Now drawing my own triangle, remember sec is hypotenuse over adjacent. So I've got hypotenuse is 13, adjacent is 5, and that's the angle theta. So what's the opposite? The opposite is 12 because it's a 5, 12, 13 triangle. Now what is tan theta? Tan theta is already 12 over 5. That's it, and we're done. Make sure to draw the triangle. Next one. In triangle, if the area of triangle PQR is 48, so we know the area is equal to, what's area of triangle? Half base times height, and that is equal to 48. We can clearly see we have a base. Remember, when we talk about height, is perpendicular height in a triangle. So we know the base is 6, so we got half of 6 times h is equal to 48. Half of 6, what is half of 6? Half of 6 is 3h is equal to 48. So h is clearly 16. So there's your, h does not mean the hypotenuse, h means the height of the triangle. So we know this distance PQ is 16. Now because we have 16 and 6, if you're dividing by 2, you're going to get 3 and 8. 3 and 8 is not a Pythagorean triple, so to find PR, you have to find the square root of, you have to use Pythagoras, which is 16 squared plus 6 squared. 16 squared is 256. You can check that up on the calculator. 6 squared is 36. You're going to get square root of 6 and 6 is 2, carry 1, 8 and 3, that's 1. Sorry, not 8 and 3, that's 9. 6 and 3, that's 9. and that's 292. So the square root of 292, I'm just going to find that, just pop my calculator and check, right? So we're going to check, okay, you can just type the entire thing on the calculator, the square root of 16 squared plus 6 squared, which is 2 root 73, and square root of 292 is 2 root 73. So my answer is 2 square root of 73. Now we want to find the value of sine theta. So sine theta is now equal to opposite over hypotenuse, right? Opposite of hypotenuse. Remember, this is the adjacent, that's the opposite, and that's the hypotenuse. So opposite is 16 over 2 root 3, 16 over 2 root 73, right? 16 divided by 2 is 8, 8 over square root of 73. Now you can't have square roots in the denominator, so we rationalize, multiply by square root of 73 over square root of 73. Now root 73 times root 73 is 73, and 8 times square root of 73 is 8 square root 73. So that's the answer